Hi folks, in today's lesson we are going to be learning about numerical approximations for limits. Basically we're going to be looking at tables. So we can estimate limits by using numerical entries into a function. If a limit exists, recall that the left-hand and right-hand limits must be equal. We approximate a limit by entering values closer and closer to the x value of interest. So let's say that we were interested in the x value 5. Okay, well, in this case we're given the table. So in this table, it tells me that I'm getting closer and closer to 5 from the left. This is from the left up here, and this is from the right. And from the left, it's getting closer and closer, it looks like to 10, and from the right, it's getting closer and closer to 10. So it would be safe to say that the limit of y as x approaches 5 is equal to 10. Okay? All right. Note, lots of students make this mistake. If you wrote limit as x approaches 5 equals 10, that is incorrect notation. It's poor notation, let's say. And you won't receive many points if you have poor notation. Okay, so please, let's try not to write limit equals. Rather, you have to have the limit of something. The limit of y. The limit of y as x approaches 5. So this is often forgotten. Okay, so let's eliminate that error early. All right, so the next thing that we'll do is look at a confusing looking function. And it looks like we're supposed to be interested in x equals 1. So take a moment and put this in your y equals in your TI-84 calculator. So I took a moment to put that in. If you're having trouble with the fraction bar like this, there's a shortcut to get there. That's alpha F1, and that'll give you that fraction bar. Well, you have to push enter then, okay? I'm not going to push enter since I've already typed mine in. So we'll push graph and take a look. Okay, and then we'll just push trace. And I realize that I'm looking for 1. So I need to go maybe on the left side of 1. So maybe 0.9. Actually, you know what? Let's get close. 0.999. All right, 0.99 gives me 3.99975. Let's do something like 0.99. 0.9. Actually, which one of those is closer to 1? I guess. Yeah, that one is. Okay, I'm doing okay. 3.997. Well, 4984, right? Maybe I should have thought this through. Maybe I should have changed how far these were apart, but too late now, right? Okay, so 0.9 we're going to say is 3.97484, and let's just stop there. That's enough decimals. Okay, so 3.9748, 3.9749, 3.997. So this is getting very, very close to 4. So we expect that it's getting close to 4 on the left-hand side, but we have to check the right-hand side. And instead of being so very close to 1 this time, maybe I'll do 1.001. That's fine. And then maybe 1.05, and then maybe 1. I'm going farther away, so maybe 1.1. Well, that did new. Okay, well, let's just type it in. So here we go. 1.001. That gives me almost exactly 4.00025. I need to stay on the screen, don't I? 1.05, 4.01, 0124. I just wanted to make sure that I'm actually getting different numbers here. And then 1.1, 4.0, 4.0249, let's say. I'm sorry, that's an 8. Okay, so from the right hand, it's also 4. So the limit, we assume, is going to be 4. Now, although we used a table on our paper, we could have used a table on our TI-84. So let me show you how to do that. If you hit Second Table, it's going to show you a table that is already made. Well, most of the time it will. I have mine set up a little bit differently, I guess. So let's go over to Second Table Set. And most tables start out like this. It says independent. It says auto right here. So this is more than likely what you got, and it probably started at 1. Okay. So we'll go Second Table Set, and we're going to go, instead of independent auto, we're going to go over to ask. Okay, and I'll show you how to use that table in the next exercise to save a little bit of time. So take a minute and type in that function there in your 84 calculator. Okay, so once you get that typed in, it might be a good time, a good practice to see the graph, but I'm going to show you a way to not have to see the graph or to not use the graph. You're going to use the table. All right, so the interesting point, they've already told us in the table, is 2. So maybe we'll go to 1.85, 1.95, and 1.99. Okay, so we're getting closer and closer to 2 on the left side. Now, how did I pick those points? I just picked them randomly. And sometimes tables are given to you and they don't have the same numbers in here, and that's okay. All right, so 1.85 gives me 1.533. 1.95 gives me 1.5106. And 1.99 gives me 1.5021. Looks like this is getting closer and closer to 1.5. On the right side of the table, we need to get closer and closer to 2. Okay, actually, when we put in 2, we get an error. So, all right, so this time we're going to go closer and closer to 2. So let's do something like 2.35. Okay, I just picked that. 2.15, and then maybe 2.01. That's fine. So at 2.01, I get 1.4979. At 2.15, I get 1.4704. And at 2.35, I get 1.4354. So in this case, I'm getting closer and closer to 2 from the right-hand side, and I'm getting closer and closer to 2 from the left-hand side. So I know that the limit is 1.5. I think that is a pretty good estimate on what you think the intended function of the, I'm sorry, the intended value of the function is. Easy for me to say. All right, so now take a look at this last example. Try to cover this up for a minute and read. Approximate the limit of g as x approaches 1,000. So here we're going towards 1,000. So what would you say? Most people stop and they say 1,500. And I'm excited that you can see the logic that it says 1,500. However, it's wrong. And the reason it's wrong is because you must go from the left and the right in order to approximate a limit numerically. All right? Unless it specifically says it's a one-sided limit. So we don't have enough information to approximate the limit of g as x approaches 1,000. All right? Now that is all for today's video. That was all about numerical approximations for limits, and catch you in the next video. See ya.